the solutions for this real quick. If, and you probably already have this written down, but we had, eventually we get down to the fact that tangent theta should equal plus or minus root 3, okay? And then from the unit circle, we were able to decipher that theta then should be at pi over 3. That will give me positive root 3 for tangent. Theta should also be at 2 pi over 3, and that will give me one of the negative versions of root 3. The other negative version is at 4 pi over 3. And the last one is at 5 pi over 3. And we got those solutions, right? Okay. And those are the solutions inside ultimately one period of theta. Okay. Now, in order to find the infinite other solutions, what we need to do is add the period of the trig ratio times k. So what is the trig ratio that we're interested in here? Which one did we use? We use tangent. So what's the period of tangent? Pi. Okay, so we add to this pi. But when we add pi, that just gets the next solutions, right? Doesn't get all of them. So then eventually I need to add 2 pi to all those red things. I need to add 3 pi, and I need to add 4 pi. So how do I keep that pi kind of moving from 1 to 2 to 3 to 4? We put that counting device of k on there, where we make the notation or the note that k is an integer. Okay? And that's kind of where we finished yesterday. We're getting to the point of finishing yesterday. But I want to talk about how there's some redundancy here. Okay? If you answer this question that way, 100% correct. Give you 100% of the points. Okay? WebAssign will even, I believe, give you 100% of the points. Okay? However, you have told me multiple answers multiple times here. And I want to talk about what I mean by that. If I look at the curve for this thing, okay, if we go to any graphing program, we get that. And we also have the other side of the equation, which is y is equal to 0. And I'm looking for the intersection of these things. Okay, so let me change my x-axis here real quick to make it a little bit easier to recognize. X-axis, let's go in terms of pi over 3. Okay, so there's our solution right there of pi over 3. There's one of 2 pi over 3. There's one of 4 pi over 3, and there's one of 5 pi over 3, right? Okay, but if I write the infinite solutions of pi over 3 plus pi k. Okay, let's see what happens here when I write pi over 3 plus pi times k, comma 0. Okay, so it's going to give me, start this thing at 0, let's go to 5, increase by 1s. All right, so there's the first one when k is 0, right? When k goes to 1, it gives me that one. Does that one already show up somewhere else in our list? Does everybody see then that in our list, if I go back to the Word document, we would have 4 pi over 3 plus pi k. Do you see that this formula generates these as well? Okay. And if you're not seeing that, let me write this. Let me go, let's say we start with 4 pi over 3 plus pi, like I use a different variable, so I'm going to go h instead of k, comma 0. Create that slider. Let's change it from 0 to 5. Let's go by 1s. So point B you see A and B are on top of each other. Okay, when K is 1, K takes A and puts it at 4 pi over 3. When H is 0, so essentially when the K value here or the multiplier here is 0, it gives me the same point that this one gave me when K was 1. Does that make sense? Okay, and K is just a counting device, so I don't really care the fact that I didn't get this solution from this one until here K was 1 and here K was 0. It doesn't matter what K was to get the solution, just the fact that it got me the solution. Does that make sense? So that being said, we don't need necessarily both of these. A lot of times they wipe away that one. Okay. And if I kept that one, okay, so if I kept that one, what could K be here so that I get this pi over 3? -1, right? So either keep this one or keep this one. Usually they get rid of this one because that 4 pi over 3 is larger than pi over 3. But that was a redundant set of solutions. Does that make sense? Okay. For the same reason, let's say here that K is 1. If K was 1 there, what do you get? 5 pi over 3. And that's what I get right down here if K was 0, right? So we're getting repetitive answers here. So maybe we wipe those away. And these are enough to produce all of your solutions. Okay? It's something to think about. It's not something that I'm going to ask you to consider when you're doing your tests and quizzes. If you put all 4 of them in, that's fine. Okay? But if you put those 2 in and you put 2 others in that are actually wrong, then the question's wrong. Does that make sense? I'd rather have those 2 or those 4. I would not like to have those 2 and then maybe the 4 pi over 3 plus pi k. Even though it's right, it provides me a thought that when I'm grading it, you really weren't sure on why you have 3 answers and maybe you should have 4 or 2. Does that make sense? All right, so 2 answers or 4 answers is kind of what I'm looking for. The reason I talk about this is Webassism obviously gives you feedback after you've missed them a couple times, right? Okay? Or maybe not necessarily feedback, it just inserts the answer that you should have gotten, right? And you might think, well, I did everything, I got 4 solutions, and it's only showing 2 solutions. This is why it might only show 2 solutions. Okay? However, if you got 4 solutions, type in 4 solutions, it will count it right. Okay? So just be cautious of that. Think about that as maybe when you miss a question, you go through all your possibilities, and it shows only 2 solutions. And then the next question is very similar to that, and you're thinking, well, I should only get 2 solutions to the last question, but I'm getting 4 on my paper. This is the reason why. Okay, is that all right with everyone? Okay. What you're going to find out, guys, that ultimately these equations, and I don't know if I showed this with you guys yesterday, but we can use U substitution. We can say U is equal to sine of theta here. Just let U be my trig ratio. And if I do that, do I get 2U minus 1 is equal to 0? Is that like an 8th grade, 9th grade Algebra 1 question? Yeah. You can solve that. You can say U is 1/2. And now what was U? Oh, we said U was sine theta. Does that get me down to the same solution we got yesterday when we didn't use any substitutions? Same idea over here. What would I let U be here? Tangent. So U is equal to tangent of theta. So then you get U squared minus 3 is equal to 0, right? Well, you can use what we call the square root method here. U is going to be plus or minus root 3, but U was tangent, right? Is that okay with everybody? I think that's a technique that you can use. I don't think many people will ultimately eventually use that with these kind of Algebra 1 equations, but I do think it might be something beneficial to use here in example 2. Now, example 2, it's still algebraically, it's you know, the end of Algebra 1, beginning of Algebra 2, factoring. It's not something that you cannot do, okay? But it's something maybe you haven't seen written this way, but we can recognize, hopefully, that this is in the format of like a x squared plus bx plus c, isn't it? Where our variable component in this case is the cosine. Okay. So is this thing quadratic in form? In quadratic form, maybe is a better way to say it, unless you're Yoda. Okay. So when I see that, I'm more comfortable factoring something like this, and I think a lot of you are probably more comfortable factoring that than you are factoring something like that. So let's make this 2 cosine squared theta minus 7 cosine theta plus 3 equals 0. Let's make that look more like this. And the way we do that is let cosine of theta, and it's always, if it's quadratic in nature, we've talked about this, if you're going to use u substitution, you're always going to let that x to the first term be your u. So let cosine theta equal u. And if I do that, then I get 2 cosine squared would be u squared minus 7 cosine theta is now u plus 3 is equal to 0. Is that now an algebra 1, algebra 2 type question? Pretty easy factor, right? Okay. So we're going to factor that. Now this is, something that you could use the quadratic formula for if you wanted to. Okay. And eventually we will see some that we have to use the quadratic formula for. But in this situation, I think the best thing here is to use the A times C method, isn't it? Okay. Take those two things, multiply them together, get 6. Two numbers that multiply together get 6, and after negative 7 are negative 1 and negative 6, right? So then we're going to go 2 u squared minus 6u minus 1u plus 3 is equal to 0. You're going to group those. Just be careful with that sign there in the middle, with that minus 1u, because that sometimes throws people off. Make sure you group that in that second binomial, or second arrangement of terms. Because now what can I see that comes out of these green terms? So yeah, 2u, right? And it leaves me with u minus 3. Now what can I see that comes out of these two that's going to help me get this same u minus 3? Negative 1. So now that provides me, what, 2u minus 1 will equal 0. That's one of my factors, correct? And u minus 3, is that another factor? So now u will be 1/2. And here u will be 3. But what was u? Cosine. So now I'm going to make that substitution. I'll have my solutions. Cosine theta is now 1/2. And cosine theta is now 3. But think about what we've done here. We have only solved for cosine theta. And that's not our input, right? Our input is theta. So we still need to work a little bit here to figure out what theta is. And if you remember what I talked about in like chapter 6 and chapter 5, there's a lot of stuff in those chapters. We were kind of trying to build a foundation for us to have some skills to solve larger problems later on. These are those larger problems. We have thought on the unit circle about cosine theta equals 1/2. When I have cosine theta equals 1/2, the question ultimately is, where is x on the unit circle a 1/2 value, right? Okay, and we've talked about this with like cosine inverse is going to find that for me. Okay, but since we know the unit circle, we're going to kind of overlooking the fact that cosine inverse on our calculator or something like that would provide the right solution here. So where is cosine equal to 1/2 on the unit circle? Okay, somebody said 60 degrees, which is fine. But if they don't make any statement about what to use, they're probably inferring that you should use radians. Okay, so I left out any directions about what theta should be, degrees or radians, so let's do it in radians. Is that the only place, though, that it's 1/2? Cosine is positive 1/2 right there, right? Okay, so shouldn't cosine also, if I move to the right from 0, 0, should be 1/2 down here on the unit circle? Anybody remember what that? 5 pi over 3. 5 pi over 3. So those are two solutions so far. Now think about this. If I'm thinking the unit circle, where on the unit circle is the x value 3? Where on the unit circle is the x value 3? What is that ordered pair right there? 1, 0. 3 would be out there, wouldn't it? Does that make sense? Does the x value ever get out here? No. Okay. If you think about it, so that's the unit circle view of it. But if I think about it as an equation, graphically, this here says when is this curve cosine, where that's a 1, when does that reach the height of 3? Never. Okay? So this produces no solutions. So my only solutions are pi over 3 and 5 pi over 3. Okay? Now, those are the only solutions between 0 and 2 pi, right? What if I want the infinite number of solutions? I start with pi over 3, and I add to it what? 2 pi k. Start with 5 pi over 3, and add to it 2 pi k. All right, and those will give me all the solutions that we need for this curve. Okay? So, it's always a good idea to graph these, see what they look like. That minus 7 cosine, is that what was in there? And was it plus 3? Okay. And I want to see where that is equal to 0, so I don't necessarily need to put 0 in there. Anybody know why it's doing that? That doesn't really think, or when I look at that orange curve, I don't really think cosine, do I? Or sinusoidal or periodic. What's happening? Why is it giving me that straight line? Talked about it before. Got to be in radians to get the curve, okay? Because it's graphing a distance against a distance in radians, and degrees obviously aren't a distance, right? It's kind of make sense, okay? But now if I just click on the curve, it's going to give me some key points right here. Pi over 3, was that one of our answers? 5 pi over 3, is that another one? How do I get 7 pi over 3? Isn't that pi over 3 plus 2 pi, right? Okay. So this was 5 pi over 3. If I add 2 pi to that, it should give me 11 pi over 3. Okay. So we're seeing that we are developing all those necessary solutions for that curve. Is that all right? Okay. My hopes are that you see what we're doing here is a collection of, when we factor and we work with the algebraic part, that's college algebra, algebra 2. Okay. When we get down to finding, I've got cosine of theta is equal to 1/2, something like that. Now we're using, chapter 5, chapter 6 of trigonometry. Okay? So really, all the nuts and bolts, all the preliminary, all the kind of intermediate algebra and just intermediate math to complete these problems, right? We're just now taking those things and slamming them together, taking those processes and putting them together in the same problem. This one here is going to produce some solutions that we got to do a little bit of work with. And I think maybe in retrospect, after going through first period, maybe it makes more sense to do example 4 first, okay? Because it really builds the necessary steps to getting a solution for question number 3. So here, this one's already, whatever the equation started off as, maybe it's a little bit more complex than this, but that's still an equation, right? But everything's already isolated. It's like saying x equals 3, okay? Well, that's an equation, but x is already isolated, right? It's kind of a trivial or kind of boring equation. This is a boring equation, but I should still be able to find out what theta is, okay? Theta is not negative 0.3, okay? This is a number that is not off the unit circle, right? We do not know that on the unit circle. So if I don't know, if I go through these problems and I get sine, cosine, tangent of something that I don't recognize off the unit circle, then how do I approach that? Okay. Well, the unit circle is just when we take a ratio and try to find the angle that's attached to it, we're ultimately using the sine inverse, cosine inverse, tangent inverse concepts. Okay. Starting with the ratio and trying to figure out the angle. So if this number is not known from the unit circle, you need to take your calculator to find theta. Remember, we've done this before. We take the sine inverse of this side, and isn't that going to give me theta on the left? And then I got to take the sine inverse of this side. So it's going to look like this. Okay? And that should produce theta for me, right? Now, the only thing I want you guys to be cautious of is that when we look at the sine inverse is only going to give us results that occur between negative pi over 2 and pi over 2. It's only going to give us those solutions. Because if I look at it, and that's from the unit circle, but if I look at it graphically, if I look at the sine inverse, it's that there, right? And what are the only outputs? So the inputs, let's do it this way. The inputs come from x equals negative 1 to x equals 1, right? Does that make sense? Those are the only values you're allowed to put in the sine inverse. But the outputs then all come from pi over 2 being the maximum output that you could produce, and negative pi over 2 being the largest negative output you could produce. Does that make sense? So it's only going to give me values like negative what? So this is like as a decimal, that's negative 1.57. This is positive 1.57. It will not give me something like 2.3 or 3.4. Does that make sense? Because those values are not in that range, okay? But we got to think about that, and that aspect of how the sine inverse works is going to impact our solutions here in a minute, okay? Because if I look back at the beginning, okay, this thing here is saying that the opposite divided by hypotenuse should be negative 0.3, right? If I draw that picture, opposite divided by hypotenuse is negative 0.3. So let's do it this way. Let's say that this is opposite. Okay, so let's say negative 0.3. And this is my hypotenuse of 1, right? Is that still negative 0.3 opposite divided by hypotenuse? But isn't there the potential for having an angle over here where that is negative 0.3 and that is 1? If I look at that blue angle, isn't that opposite of our hypotenuse still negative 0.3? Does that make sense to everybody? So these are the solutions that I'm looking for, but my calculator is only going to give that red one. Is that all right with everybody? And the format that it gives that red one might not be very convenient for us either. Okay, so we'll talk about that here in a moment. So when I go sine inverse, now I'm going to do this in radians, okay? Because that's usually what they're going to ask for. But maybe when we're done, we can go through and do it in degrees and see if we can develop an understanding of it maybe a little bit better. So I'm in radians, so I go second sine of negative 0.3. It gives me negative point. So this angle, should have drawn this a little bit bigger. That angle right there, they're saying is negative 0.30, let's go 47 radians. Okay. If I did it, maybe I just do it right now in degrees. Let's put the mode in degrees so you can see the difference here. They're giving me negative 17 degrees. So that red angle is negative 17 degrees. Does that make sense? Okay. Now, I'm never going to answer my question, though, with a negative theta. I want a positive theta. Okay. So, how do I deal with a positive theta? We're talking now as that angle. Instead of that little black angle moving in the negative direction, we're now talking about this purple angle moving that way. So what would be, and it's going back to coterminal angles, what would be the process that I would use with that number of negative 0.3047? That's going to give me that positive coterminal angle. Okay, add 2 pi to it. Okay, or so you're saying add 2 pi to the negative value, right? Okay, remember that negative just tells me a direction, correct? So if I'm looking at this right now, and I think some people will maybe appreciate this, the negative just tells me that I'm going from here that way, right? Okay, but it's still a 0.3047 radian angle if I just look at it as an angle and don't care about the direction. Does that make sense? How many degrees would that be, or how many radians would that complete circle be? 2 pi, right? But are we going a little bit short of that to get to there, to get to that ray? So isn't it, and you can think about it as 2 pi plus the negative 0.3047, but that's the same thing as 2 pi minus that thing, right? Okay. So I'm going to take 2 pi plus, and then I'll just recall that number, 5.978. Okay, 5.978 is one solution for theta. Okay. But looking at, and I'm going to redraw this red picture just because of the clutter. If this was negative 0.3, this was 1. We also said that we could have this angle over here where this is negative 0.3 and this is 1. And now try to figure out what that theta would be. Does that make sense to everybody? Okay? Because the calculator is not going to give that one to you. Okay? The calculator really didn't even give you the red one. You had to do some work to get that red one, right? So how do I get that blue one? Well, what is the relationship between that angle right there of 0.3047 radians and that angle right there? They're the same, right? They're reflections of one another across the line x equals 0 across the y-axis. Okay? So that angle right there is 0.3047 again. Well, what would just that red angle right there be? Pi. So how do I go from there to there? I add pi, right? Okay, add pi to my 0.3047. So I'm going to take pi now, just because I'm trying to recall numbers, not the type of thing I'm going to go minus and negative. Is it minus and negative? Something's adding. Okay. So hit enter there, and I get 3.4462. Okay. And that then is the solutions inside one interval, one period, for when sine of theta equals negative 0.3. How can I check myself? I now have my thetas, right? I now have my thetas that should be the input for that right there to get this output. So shouldn't I be able to take sine of 5.978? Make sure I'm in the right mode. Oh, man. Did I do anything wrong with those numbers? I don't think I ever used. No, I think it should be all right. Do you agree that's negative 0.3? And why is that number different? Yeah, I had rounding error. And that's not exactly what theta should be. It should be a little bit, obviously, probably infinite decimal places, but whatever. I'm going to do the same thing for 3.4462. Would you agree that that's negative 0.3? The more decimals I go out in this one up here, the more zeros it's going to put throughout here. The more decimal places I put here, the more these turn into nines. Okay? But we can infer because of rounding error that we have done things correctly. Another thing to kind of think about is, looking at these two angles, we know that angle right there should be between 270 degrees, 360 degrees, right? Or, a little bit less than 6.28 radians. Is that less than 6.28 radians? Okay, and I think this is about 4-something radians. Okay, so we should know that our answer should be between those two numbers. Obviously, this number here is 3.14 radians, right? Is that number more than that, which is what that blue angle is kind of representing, right? Blue ray would be bigger than 3.14, and 3.44 is. Okay, like I said, if you're doing it in degrees, that's fine. So I think we had, what was it, negative, let me just go put back into degrees. We did sine inverse of negative 0.3. It would give me that in degrees. So it's a negative angle, so adding 360 gives me the positive version of it, right? The positive coterminal angle. So that there is one of my answers. If I take in degrees sine of that number, I get that negative 0.3, right? However, a lot of times that number is not going to be what they want because it's in degrees, and we're getting to the stage where we're going to probably be phasing out degrees more often and using more radians. So they're going to ask us to write this in radians. Well, if you do all your work in degrees, that's absolutely fine, but then just change it over to radians by using that conversion tool, right? Does that give me my 5.978 number that we found by doing it in radians? And I found in the past that some people like that. They prefer to do everything in degrees because it gives the picture, and they're able to understand the picture a little bit better, right? But then they got to remember, when I answer everything in degrees, the question probably wanted it in radians. So I got to convert back over, okay? So how does that impact other questions? That process actually comes up a lot in some of these types of equations, okay? So example 3 here says, solve this equation, 5 sine theta cosine theta plus 4 cosine theta equals 0, okay? It's a little bit of a different format of an equation that we haven't seen so far. If we look at that, it's not a traditional like algebra 1, algebra 2 multi-step equation. It's not a quadratic equation. It's not a quadratic form. There's no powers of 2 there. But it is a factoring question. It's probably one of the first factoring questions that you ever dealt with, okay? If I had something like this, let's say that I had 5uv plus 4 v equals 0. What do those have in common? V. Okay? V in this case would be your greatest common factor, right? Well, let's look at this. What's in common in that first product in this second term? Cosine. Factor your cosine theta out. If I factor a cosine out of this, and remember, factoring is just division, right? So if I divide this thing by cosine theta, don't they cancel and leave you with just what? 5 sine. Divide this thing here by cosine theta, and it leaves you with just 4. Is this a number? Cosine theta just a number? Is 5 sine theta plus 4 just a number? When I multiply 2 numbers together and I get 0, what's it tell you about those 2 numbers? One of them has to be 0, right? So cosine theta is 0, or 5 sine theta plus 4 is equal to 0. Does this one give me sine of theta equals negative 4/5? And this one's kind of trivial in regards to solving. It's already done, right? If I use the U substitution concept, I would get something like that. Now, because I had 2 variable terms, sine and cosine, I've used 2 variables. A lot of times use U and V. But that eventually give me V equals 0. V was cosine, right? And I get 5u plus 4 equals 0. If I solve that, u equals negative 4/5. U was sine, right? So if you want to use that approach, that's fine. But now what do we do? Well, you know these solutions from the unit circle hopefully pretty easily. Where is cosine of theta equal to 0 on the unit circle? Yeah, pi over 2 and 3 pi over 2. Okay. Now looking at this one here, I'm just going to move this up, give myself a little bit of room, maybe get rid of this stuff as well. Do you know on the unit circle where sine is equal to negative 4/5? Is there a y value on the unit circle of negative 4/5 that we have memorized? No. Okay, and you're going to find out the reason why is because that's a really ugly radian. Okay, pi over 2 is real nice. 3 pi over 2 is real nice. The solution for this is not nice. Okay, it's kind of ugly. So what do we do to find theta? We're going to use sine inverse of negative 4/5. Okay, I like to draw a picture. Because sine inverse of negative 4/5, what's going to happen? We're going to do it in radians. The sine inverse of negative 4 divided by 5 gives me that there. Negative 0.927. So it's giving me something like this angle here. Negative 0.927. Okay. If I were in degrees, it would give you negative 53 degrees. Okay. Well, if I have negative 53 degrees, how do I get the positive version of that? Add 362. Okay. So if I'm at negative 0.927 radians, how do I get the positive version of that? Add 2 pi. Okay. So theta should equal negative 0.927 plus 2 pi, which will equate to, so grab this thing up here, add 2 pi to it, 5.35589. Okay. But we're not done, because the sine we said was negative 4/5, right? Is the sine negative in any other quadrant? Isn't the sine negative over in this quadrant as well? What do you think that angle right there is? It's the same as that one, right? 0.927. Okay? They're mirror reflections, right? The negative, remember, is just a direction, so I'm just going to transfer the 0.927. How do I find, then, that angle theta? Add pi to 0.927. Now, it's not the maybe most logical way of doing it on my calculator, but that should give me 4.068. Okay? So theta is equal to 0.927 plus pi. Okay? We'll talk tomorrow or Monday, I guess, about how we can go back and check these solutions. I thought I'd finish this and show you how to check this stuff. Really, basically, these are our input values. Okay, these two and these two to this equation. So all we got to do is type these values into this equation. We should see that they get 0. Now, that can be cumbersome because of, one, you got to check 4 solutions, but 2, you'd be inputting those solutions 3 different times. So we can use our calculator here to do this effectively for us. Essentially, what we need to do is go to Y1 and just type in the original equation. We know we want it to get equal to 0, so that's what we'll be looking for when we ask the calculator to evaluate it. And then we're going to go to table set, which is second window, and we're going to go down to the independent variable and make sure ask is highlighted. Okay, we'll hit second table then, okay, which is the graph key, and it should get you to this. And this ultimately all this is an x and y table, just like you learned in Algebra 1. You're going to put in the x value that you're interested in, and it's just spit up back the y value that's associated with it, okay? So we want y values here that are 0, and if I type in pi over 2, we get 0. If I type in 3 pi over 2, we get 0, okay? And then if we type in 5.35589, we get negative 2 times e, or e to of negative 7. What that means to us is it's scientific notation. It means 2 times 10 to the negative 7th. And if you think that's 6 zeros and a 2. And hopefully you can make the argument that because of rounding, that is not 0, but it's really close to it. And then 4.0689 should give us 2.2 e to negative 5. So that's, what, 4 zeros and then 2. So that's going to be, we're going to make the argument that that's 0 as well. And the reason they're not exactly 0 is because we're using that rounding error there. But
That's how you would check yourself. Um, what happens with a lot of these questions is that people get these two, and they check those two and they work, but they don't know how to get these two, so they don't get these two. Um, so you get half credit, but I guess what I'm trying to say is that it's not so much that they get wrong answers, it's that they leave out potential correct answers. So kind of always keep that in mind as you're going through these problems.